The first question is on our screen. It's been given to us by Mabutla Valentine Machejo. Mabutla, thank you for this lovely question. It's a question that deals with differential calculus and it deals with optimization, meaning find the maximum value and the minimum value under certain conditions of whatever they want us to find. Let's have a look. They give us a function, f of x, which is 4 minus a quarter x squared. And they say that's the white function over here. They say there is a point B that lies on this function. And the D is the point x and 0. Now they want to know if this BD is parallel to the y-axis. Now, folks, that is important because we need this to be a right angle. Why do we need this? Well, they're asking us where must D lie on the x-axis so that the triangle BOD has a maximum area. Okay, so for us to be able to find that, we need to be able to find the area of the triangle, BOD. Okay, so that's ultimately where we're going towards. Let's see the first question for 1 mark. They're asking us to find the coordinates of this point B. Now remember they said B lies on this curve in terms of x. Now folks, if you have the equation of a curve, you have the relationship between the x and the y values in the coordinate pairs that lie on that curve. Let's see. Because this is the curve 4 minus x squared over 4, I can say, okay, the independent variable is indeed x. It's the same as the one here at D. But the y value would be determined by taking that x, and I'm going to write it as minus a quarter x squared. In other words, the y values when x takes on a particular value. So that was for 1 mark. Why did they ask us that particular question? We'll see why now. Now they say, show that the triangle of the area rather of triangle BOD can be given as 2x minus x squared over 8. Okay, so this is what we need to show. So we needed the height, and hence the line BD being perpendicular. That's the one thing. The second thing is, if you look on the screen here, if I want to find the length of this line here, which is going to be the height of the triangle, and this is going to be the base of the triangle. To find that height, I need this y value, and I know that that y value is 0. Okay, do I have that y value? Indeed, that was why they asked me to write this coordinate pair in terms of x. So I can start immediately and say the area of triangle BOD, as we learned it in lower grades, is a half base multiplied by the perpendicular height of my triangle. Now the base length is from there to there, which is given by this x coordinate. So it's a half x multiplied by the height h, and the height h is this 4 minus a quarter x squared. Okay, base times height. It's as simple as that. We could have put a square underneath it, or not a square really, a quadrilateral, a regular quadrilateral like a rectangle. We can put under there and ask you under the where must D lie so that the area of the rectangle is a maximum. Okay, the minimum will obviously be 0. Okay, and the same for this triangle. The minimum area will be 0, and that will be if this point B lies on this x-intercept, then it will only be a line. There won't be a triangle, or when it lies up here. Okay, so let us just multiply this out. We get a half times 4 is indeed the 2x, so that part is correct. Minus 1 times 1, 2 times 4 is minus 1 over 8. X times x squared is x cubed. So this then is our area in terms of x. Now that was asked for a silly 2 marks. This whole question is worth a total of 7. The b coordinate was 1 mark, this was 2 marks. It's literally just getting the right values in for the base and the height, and then just this they gave you. Now let's say you didn't get to this answer, to their answer. Your answer because you made some silly error somewhere, or you didn't know where to start to find that height, folks, then use their answer to answer the last 4 marks in this question, which now says, and this is what makes this question so lovely, they say determine how far point D must lie from the origin to give a maximum area. So we're going to say to maximize the area, we need to take the derivative of the area and we need to solve it equal to 0. Okay, why is that the case? Folks, this here, if you draw this, a quick graph will have points that have, it will actually be the other way around. So it will be like that and like that and like that, more or less. It's not 100% accurate graph. Why did I know it would be more or less like this? This area will be behaving like that because of the cubic and there's a negative in front of it. So we're looking for that point where there's a local maximum on that curve. Okay, and how do we find it? We find it by saying the derivative is 0. So the area is represented by the cubic curve. If I now differentiate that, I get 2 minus 3 over 8 x squared is the derivative, and that is equal to 0. Okay, so this x disappeared. All I need to know is where this is 0. So what do? I throw my 2 over. So I get 3 over 8 negative x squared is equal to minus 2. The 2 negatives say goodbye to one another. And now it's baby algebra. I multiply by 8 and divide by 3. So I get x squared is equal to 2 times 8 is 16. And the 3 comes over. Just to remind you, what did I do? I multiplied both sides by 8 over 3 to get rid of my fraction and get my x squared by itself. Okay, so finally, this question that Mabutla sent us has an answer. It has x is equal to plus or minus 4 divided by the root of 3. Now remember, folks, we bring in the plus or minus because we are initiating the square root. Now we go back to context. We say, okay, if I look at my graph, clearly my x is on the positive side. So, but x is positive here, so x will be 4 divided by the root of 3. So it must be 4 divided by root 3 units away from the origin. Mabutla, thank you for that question. It was quite nice working through them. Remember, folks, you know your mensuration formula. By that I mean you know your surface area formulas. You know your volume formulas. Learn them off by heart because you apply those things as applicable in these type of problems that you solve in differential calculus.